If you got into a spaceship and traveled long enough and fast enough, could you eventually loop back to where you started? Assuming you don't accidentally collide with another planet or star and no black hole swallows you along the way. This is What If, and here's what would happen if the universe is a loop. We don't know much about the universe. We have no idea how big it is, or where it starts or ends. For years, scientists thought the universe was flat, like a piece of paper, and that if you kept traveling in a straight line through space, you'd just sail off into infinity. But a new study of cosmic microwave background, or CMB, might have just ruined everything we thought we knew about the universe and its shape. What's in it for you? Well, if the universe is a loop, it would mean that a kind of time travel might just be possible. Before we move on to the time travel, let's get the theory out of the way. I'll start with Albert Einstein's theory of relativity. Einstein predicted that space could bend in different ways, meaning the universe could be flat, or curved, or closed. The flat universe was the most likely shape of all, and by that I mean that it fit our current understanding of physics. But then, researchers found something strange in the cosmic microwave background. Figuring out the shape of the universe isn't an easy task. We've never sent a single space probe to the outermost reaches of our universe. Well, we don't even have spacecraft that could possibly go that far. And this is where the CMB comes in handy, the cosmic microwave background. It's microwave radiation that's spread throughout the universe, a relic from its very early ages. Because it's so old, CMB serves as the main source of data about the universe and its past. And by measuring it, scientists can get all kinds of cosmological information. Now, this is the Planck mission satellite. It was sent to measure temperatures in the CMB, among other tasks. But the data that this satellite brought back didn't quite add up. It suggested that gravity was bending the CMB more than the researchers expected. And this isn't something that existing physics can explain. Maybe we were wrong about the shape of the universe. Maybe it's closed like one huge inflated balloon. There is a way to test this theory, although it's quite hypothetical. So put your helmet on and buckle up. It's going to be a long ride. Oh, and by the way, for this task, you'd have to not age for billions of years. You'd also need to build a spaceship with warp drive technology. Equipped with all that, you'd begin your journey around the universe. Don't say I didn't warn you. This one-way voyage would take you billions of years. If the universe is much, much larger than what we can observe, you might only get a third of the way. But if the universe is a loop that's less than 15 billion light years in diameter, you might return to your starting point. That would be solid proof that the universe is indeed a loop and that physics as we understand it doesn't apply. And what was I saying about time? Oh right, Albert Einstein suggested that space and time are connected. So if the space of the universe is looped, could time be looped as well? It might be. The universe could be repeating itself over and over again, from the Big Bang to the Big Crunch. That would explain how the galaxies, with their stars and planets, came into being. And if we live in a looped universe with looped time, maybe, just maybe, one of those young galaxies you can see out there is actually an infant version of the Milky Way. That may not be the kind of time travel you expected. The thing is, the shape of the universe wouldn't have any effect on you or the Earth, or even the entire galaxy, but it might just give us a loophole in covering the astronomical distances involved in exploring the universe. If you really want to travel through time, it would take more than just a different shape of the cosmos. But that's a story for another What If.